Okay, so in part 1, we did this first page of study notes, and now we're going to use it as we do some problems here. So we're going to start off, and it says we're going to do translations. That means we're going to start with a slide, and it says to describe it in words. So you do have to look, this is the A prime here, and this is the A. That means I'm going from this one to this one. You have to get them going in the right order. So when I go from here to there, this is going to the left. 1, 2, 3, 4. And up. 1, 2, 3, 4, 5. Then it says give the coordinate notation. Well, in the x direction, this is just like what we did here. When I'm going to the left, that means it's taking the x and I'm minusing from it. So x minus 4. And then I'm going up 5, that's just like here, that's where the y is going to be plus. So that's y plus 5. Okay, now it says write C prime after C is translated up 5 units and left 7 units. Well, let's do this to it. Up 5, right here, and left 7. 7 right there. So where does it end up? Well, it ends up right here. So that's at 1, 2, 3, negative 3, and 1, 2, 3, positive 3. Negative 3, 3. And then it says write C after it undergoes this translation. So now let's go back to C. Negative 4. Well, we just talked about if I do x minus, that means it's going left. So I go left 4. Which ends up right here. And then at plus 6, y plus 6, y plus means that's an up. So I'm going to go up 6 from there. And I end up right here. This point right here is 0, 4. So that's where it ends up. Now we're going to do it where I just have the coordinate notation, I don't have a graph, and it just asks me to describe it. Well, if the x is a plus, that means it's going to the right, this much, and y being a minus means y is going down, so that's down 1. Now it says, what if I give you this point, and I just use this notation on it? Well, that's the easiest way with the notation is I just take this and plug it in for the x. Negative 3 minus 4 is negative 7. 6 plus 2 is 8. That's it for those translations. Now we're going to do some reflections. Describe the reflection in words. So we're going to do the same thing we did above, but now we're doing it for reflections. So this is E prime. So here's my E. It's at negative 1, 4. And this one is at 4, negative 1. So am I reflecting over the x-axis or the y-axis? No, because this would be down here or it would be right there. This one is what kind? Well, let's look back at our notes. Our three main kinds we have is over the x, the y, or over this line, y equals x. Maybe it's this one. If I draw that one in, that's what I've done is I've reflected it across this line right here. I can also tell because what I did was I swapped the x and y. Negative 1, 4, 4, negative 1. So this is a reflection across y equals x. This has to give the coordinate notation of this reflection, so this is going to be where we just swap the x and the y. Just like we have right here, it's just a swap of the x and the y. Okay, now we're going to do the same thing we did above, where we're going to take and find C prime if C is reflected over the x-axis. Well, this is the x, so if I reflect it across the x-axis, it ends up right here. And that's at negative 2, negative 3. What if I go back and take, I meant for this to be over the y-axis here. What if I go back and take C and reflect it across the y-axis? Well, that puts it right here at 2, positive 3. Alright, now we're going to take D, and I'm going to reflect it over the line y equals 0. We have to remember, what did we say on this other page about y equals 0? Y equals 0 is the same thing as the x-axis. So this one right here is the same thing as the x-axis. So I'm going to reflect it across the x-axis here. Ends up right here. And the point is -4, 3. Now I'm going to take it and reflect it over the line y equals x. Well, that's this line right here. So it's going to end up right here. I can also do it that I'm going to switch my x and y's. This point here was at -4, -3. My new one is at -3, -4. Okay, now we're going to do some where there's more than one change. And we're going to write first in words what happens. Well, first, this is the line y equals x. First, it's a reflection across that line. Then, what happened from 2 to 3? Well, it goes up and to the right. It goes from 2 to 5, so that's up 3, and it goes over 1, right 1. Okay, this next one we have a rotation, and I need to go from 1 to 2. So if I go this way, that's going to be a clockwise rotation, and we said that everything is counterclockwise, so I'm going to go the other way. So I'm going to go this far, and that's a rotation of 270. And that's counterclockwise. If I went the other way, I'd have to say that it's clockwise, because we agreed that counterclockwise is going to be what it is unless we say otherwise. Then from 2 to 3, we have a translation down. So it doesn't show on here how far it goes, but I'm just going to write translation down. On here we have, first I have a translation up and to the right. So up, how far? Well, it goes from 5 to 10, so that's up 5, and right 1. And then I reflect from here to there, that's reflecting across this line y equals x. Reflection across y equals x. Okay, now we're going to do rotations, and again, you may want to look back at the page where we wrote down on part 1 our rules for the rotations. So first I've got a rotation here and it says to describe it in words. Well, this goes 2 squares, so this is a rotation of 180 degrees. And then it says to give the coordinate notation for this. So I can do it either by remembering what that is, or I can just look at my points. This is at -1, 4. And this is at 1, -4. So what happened? Well, it stays in the same order, but both of these change signs, so it's got to be a negative and a negative. That's actually exactly what we have over here for 180. It stays in the same order, and they're both negative. Okay, now it says let's find G after it's rotated 90 degrees counterclockwise. Well, counterclockwise is this way, so 90 degrees is going to put it in this quadrant. I'm at 2, 3, so I'm going to be at 3, 2 here. And I'm going to be at 3, -2. And I can also look at my rules. It says when I go 90, I switch the x and the y, and I change the sign of the first one. This was at -2, 3. This is at -3, -2. What if I take G and go 180 degrees? That's going to put it over here, and my rule here is that it stays in the same order, they both just become negative. So this is going to be 2, -3. Both of them change signs, but it stays in the same order. Now we're going to do the next two. What if I take and go 270? Well, that goes this far here, and our rule is that I'm going to switch the order, so it's going to be 3, and the second one is the one that becomes the negative. So it's going to go to 3, 2 right here. And 360 means I just go all the way around, so it's going to end up right back where it started, which is what our rule says, is it just stays the same. 3, 2, negative 2, 3. Then we also talked about these symmetries. Lines of symmetry just has to do with how many places I can fold this on. Well, for instance, on this snowflake, I could fold it along each one of these, so that's 3. I could also fold it in between like this. So that's 1, 2, 3. So that makes 6 total. What about this star? Well, we talked about stars before. Basically, I can do it through each one of these points, like this. I could fold it on each one of that, so that's 5. Rotational symmetry, we said you just take 360 degrees and divide it by how many times I could rotate it and match it up. Well, if I start with this point here, and I rotate it one time to there, it'll match up with this. And I rotate it one time to here, it'll match up with that. And then if I rotate it back, it matches up with that. So that's 360 divided by 3 is 120. This little funny shape here, if I start here and I start rotating it, it'll match up when I get to here, and then it'll match up again when I get to there. So that's 360 divided by 2 is 180. And then finally, for each of these shapes, choose if it has rotational or reflectional symmetry or both. Well, this one definitely has reflectional right here. I could fold it in half and it would match up. But rotational it doesn't, so this is just reflectional. This one, if I fold it, will it match up? It won't, because it has these little weird things that just go in one direction. That's where it's going to match up every time I rotate it this far. So that's just rotational. What about this flower? Well, it'll match up if I fold it, like along this line it'll match up, but it'll also match up if I rotate it along this way, so that one happens to be both.